My name is Tanay Pant, and today I'll be presenting a session on web-based virtual reality. I'm really excited to be amongst you all. So, how many of you have had any experience with virtual reality? That's good. And how many of you had some experience with web-based virtual reality, maybe used A-frame or something? Good. In this presentation, we'll be discussing virtual reality, web-based virtual reality, A-frame, faster web VR prototyping with A-frame, and finally, the variety of cool stuff that can be accomplished using A-frame. So what is virtual reality? Virtual reality is a technology platform that transports you to interactive, realistic, and immersive 3D environments. It's the next platform that will change how we work, play, and communicate digitally. Yeah, that's me. I am a tech speaker from Mozilla Foundation. I'm an author, and I've written books on Firefox OS, building a virtual assistant for Raspberry Pi, and my latest one is on learning web-based virtual reality. I'm also an Intel software innovator in the field of IoT and a web developer. So before we get started with the presentation, I'd like to pump up the energy in this room, so I'd request if everybody can stand up for a little moment on their seats. So we are going to do what's called the open web stretch. So this is how it goes. We start by taking both our hands and reaching to all the open source streams. Reach really high up there. Then we bend down to touch our toes and reach the grassroots. Yeah, come back up. Then we blow away the winds of change. Then you reach out to shake the money tree for fundraising. Give it a good shake. Yeah. And then you lean left to avoid the NSA. You lean right to avoid the NSA. Then you go all around Matrix style to avoid the NSA. Yeah, that's it. We are done. Please have a seat. Thank you. I still remember my first virtual reality experience. It was in the form of an Android game, and it was called Roller Coaster, and it had the simulation of a roller coaster. Probably some of you might have tried it. That application blew away my mind, and I got involved with virtual reality after that. So other than game development, there are some other different use cases of VR as well. So if you're an engineering student, you can design 3D models and do CAD development, and you'll be able to visualize your models in 3D, and that's really helpful. If you're an artist, you can paint in 3D using Google Tilt Brush or A-Painter. Not so long ago, Samsung did an experiment, and what they did was they created a simulation in which the virtual reality users stood on the edge of a really high-rise building. And they used it to cure acrophobia, that's fear of heights. And that is how virtual reality can also be used in therapeutic causes. This shows how VR can be used in the development of the society as well. VR is being backed by some of the largest corporations in the world, like Google, Facebook, HTC, Sony. Everybody wants in. These devices range from tethered to untethered, cheap to expensive, and some even have controllers and tracking sensors. HTC Vive with Steam currently offers the most compelling experiences of all, but we never know what the future might hold. So we see a lot of different devices, platforms, and systems competing with each other. So can you guys recognize these devices? The one on the top left, Cardboard. The second one, Google Daydream. Yeah. And third one, Samsung Gear VR. Then this is Oculus Rift. This is Sony Nintendo. And then last one is HTC Vive. Yeah. Can anyone recognize the device in this slide? Yeah, you got it. This is just a guy wearing his headphones wrong. I'm just kidding. So the current VR ecosystem currently have some very compelling problems, and some of them are there are gatekeepers, and app stores and corporations control the distribution of these applications. They can autonomously take down and block content, which is a problem. Downloads and installs are a barrier to consumption because to develop even small business pages or small applications in VR, you'll have to make gigabits of downloads of SDK, which is really a problem in countries where internet is not as readily available. And internet is costly as well. And then they have a closed ecosystem. And there are proprietary engines and steep learning curves. You have to learn to use the whole SDK in order to build even a small application. If we want VR to be successful, we want a platform without these points of friction. And that platform is web. WebVR is an open virtual reality, a platform with the advantages of the web, and it is powered by the internet. WebVR is open. Anyone can publish content online, just like a website, and you don't need to submit it to any app store or app store. And it follows open source culture with open source standards. WebVR scenes are connected, and they allow you to traverse between different worlds. So if, for example, we have simulation of this room, there would be a hyperlink, and you'll be able to teleport yourself to different scenes, for example, say Colosseum, and just like Doctor Strange. Then WebVR experiences are instant. You can just send your friend a link on Facebook or Twitter, he'll click on it, and he'll experience it immediately. No downloads required. The web that we see today is a subset of the web that can be realized using the power of WebVR. And web has the advantages that can make virtual reality realize its potential fully. A little bit about the WebVR API. The WebVR API provides optimized rendering paths to headsets, and they provide the axis position and rotation data. The initial WebVR API was drafted by Mozilla Foundation, but now it has been adopted by the working W3C community group. So as you can see, it has been implemented in some of the major browsers across the world, the Firefox Nightly, Chromium experimental version, Samsung Internet, and mobile polyfill. So it's not just a specification anymore, it has been implemented. Metaverses. Metaverses are shared, persistent, and collective virtual spaces. These are like alternate digital reality where you can live, work, or play in. It's basically like Matrix in the movie Matrix. The essential thing about metaverses is that they should be open, decentralized, and connected with each other. And web is the best platform to fully realize the potential of metaverses. So where do we begin? 3JS is a framework that abstracts WebGL, 3D, and WebVR, but it's not that accessible. How many of you have had any experience with 3JS? Good. So before we move on, I'd like to show you a live demo so that you can get a feel of what WebVR looks like. I'd request everyone to open this URL, drawvr.com. You can open it either on your mobiles or laptops. Opening with laptops might be better because you need hand controllers and it would work well with the WASD keypads. But nonetheless, you can experience it. Okay, I'll get started. So I pre-recorded a video of this. So as you can see, if you're on a laptop, you can use the cursor pad to change your field of vision. And if you're on a mobile, you just move it. And you can't move around with the mobile because you would need controllers for that. But in the laptop, you can use the WASD keypad to move around. Now, I'm in an empty room with different portals, and I walk. Okay. Apologies. So I walk into a store, and this is a hyperlink which teleports me to a virtual reality store. And you might notice that on the bottom right corner, there's a symbol of goggles. So if you are on a device that is, or a browser that is compatible with WebVR, the field of vision will split into two, and it would be compatible and ready to go in the Google Cardboard. So as you can see, there are posters and products lying around in the WebVR store. So that's the sad truth of life. Using 3JS, it's not really very easy to create WebVR experiences, because for doing that, there are huge obstacles even for small prototypes and experiments. Boilerplates needs updating every time when there's browser quirks, you need new versions of WebVR, you need new versions of 3JS. So for creating even a basic WebVR scene, you'll have to install VR effect, preload assets, initialize scene, set up camera, set up lights. You need to set up the responsiveness. You need to listen to window resize, create render loop, and there's a lot of boilerplate code. So Hello World is a program that's the most basic program for creating anything. And how many of you might like to work on this to create a Hello World VR program right now? Okay, that was expected. So what if I tell you that you can encapsulate all of that into one line? Introducing A-Frame. A-Frame is a declarative framework for building virtual reality experiences on the internet. It was launched last December. And why A-Frame? Because it is easy for developers to create VR content without graphics knowledge. And it is easier for prototyping and experimenting WebVR and VR UX faster. It's the perfect vehicle to kickstart the WebVR ecosystem. This is how a Hello World program in A-Frame looks like. As you can see, it's just in HTML. And for getting started, you just have to include one script tag, which includes the A-Frame.js minified version of the library. And there are no installation or build steps required. And just one line of HTML, one tag, ascene, that allows you to control components like canvas, camera, renderer, lights, render loop, WebVR polyfill, and VR effect. For further development, we put stuff inside the ascene tags. Here are some of the basic 3D primitives that are included. As you can see, in this scene, I've included a box, a cylinder, a sphere, a plane, and a sky. You can use the HTML attributes to define the behavior of these components. And as you can see, I've defined colors, and I've defined position in X, Y, Z axis. And then there's you can define rotation to define the orientation of the object. And different components have different attributes. Like for a cylinder, you can specify the radius and height of cylinder. And for a sphere, you can specify the radius of the sphere. Let's quickly take example. Here is a possible use case of A-Frame in case it gets integrated with Wikipedia. So that would mean that if you have to see some monument, for example, I've taken the example of Burj Khalifa. You would probably visit Wikipedia in future and would be able to see how the building actually looks like. And it becomes pretty cool when you are able to visualize things sitting just at your home. Since A-Frame is just HTML, it's compatible with all of the existing libraries or frameworks. And HTML acts as an intermediary level between WebGL and 3JS. Under the hood, A-Frame is just 3JS, and it's a declarative library for 3JS. As you can see, A-Frame works with D3, Vue, React, Redux, jQuery, and Angular. And if you're a data scientist, or if you like to make visualizations using the D3 library, then you can do these visualizations in a 3D simulation. And this is an example. It shows A-frame integrated with Firebase. And I'd like all of you to open this URL. I'll wait a minute. So I've used Firebase here to create sessions as new users join in. And you can do it by opening the URL in your laptops or mobiles. And as you can see, it's a simulation of the conference room that we are sitting at. And there's the speaker. And for recording this video, I have used my laptop, and I had used my mobile phone to create another session. So what I did here was, now if you'll have a look at the screen, you can see with the other session in my mobile, when I tap on the screen, the guy starts to wave his hands like crazy. And when I put my mobile like this, he looks down. When I put my mobile like this, he looks up. And then tapping the screen makes him wave his hands like crazy guy. Moving forward, A-frame is an entity component framework. Have any of you have any experience with Unity? Okay, so you guys might be able to relate to this because entity component system is really popular in game development and is used by Unity. All objects are in the scene are entities that are inherently empty objects, and you'll have to add components to attach appearance, behavior, or functionality to these entities. The 2D web was the one where every element was fixed, but the 3D VR web is different. And it has different objects of varying like infinite types and complexities. Hence, the entity component system provides an easy way to build up different kinds of objects for your web VR scene. So we compose an entity with the A entity tag. By default, it has no appearance, functionality, or behavior. We'll have to plug in components to make it work. As you can see, this is the construction of an entity, and the syntax style is similar to CSS style. The component names are HTML attributes, and the component properties are HTML attributes value. So I have put in different behaviors and appearances options for this by defining the geometry, material, positioning, rotation, and scale of this. You can also write your own components using A-frame, and for that, you have to define a schema. And a schema defines how data is parsed from the HTML. And you have different lifecycle methods, as you can see, init, update, remove, or tick, for defining how the component would work. And if you have had experience with Android, you might probably relate it to Android development lifecycle. The applications behave in a similar way. These are some of the components that ship with A-frame. We have position, rotation, hand controls, scale, light, material, geometry, sound. By the way, if you are worrying about having to build a scale model of scale replica of some monument, like say Colosseum, using A-frame, don't worry, you won't have to build it using just boxes or cylinders, because there are two ways you can create scale models in A-frame. One is using the Collada model, and second is using the object model. The Collada model primitive displays a 3D Collada model, which has been created from a 3D modeling software, or maybe you might have downloaded it from the internet. The object model component loads a 3D model and material using a .obj file. So you can create 3D models in 3D modeling softwares. You can create a file, and you can just include them in your web VR scenes. Since HTML, A-frame is HTML and it's fully extensible at its core, these are the components. I don't think it's properly visible, but these are some of the components that has been contributed by the community. And components can do whatever they want because they have full access to 3JS. The components system is the lifeblood of A-Frame. And you can simply include these components in your scenes by using a script tag, and just done. No build steps are required, and you can use them straight from the HTML. So this is an example of advanced developers empowering new developers to create a collaborative environment. All these components are collected and are made available in the A-Frame registry. It's like a store of components that the registry team makes sure works well and works out. People can browse components or install them and see the showcase at the A registry website. Now, if you are building a web VR scene, it's fine that you don't have to create things using primitive objects like box, cylinder. You can include models, but when you're creating a new scene, it becomes annoying to have to put in details of the positioning of the object using XYZ axis because you can't be sure of what you want the scene to look like, and you'll have to do trial and error a lot. So to solve this problem, A-Frame brought in an amazing feature called A-Frame Inspector. If you guys can open aframe.io on your laptops and open up a scene which is called the Anime UI scene, you'll be able to invoke the A-Frame Inspector by pressing Ctrl, Alt, and I on any A-Frame scene. And this will open up the A-Frame Inspector. So as you can see from the A-Frame Inspector, you can select any object, drag it, translate it, rotate it, scale it. You can create new point objects, point light sources. You can change the brightness, colors, shading of the materials. You can change the perspective from where you are looking at the VR scene. You can introduce new objects to the VR scene without having to write any code. You can change the radius, convert it to a circle, convert it to a toroid, or edit them in any form that you deem fit. And this is how you can edit using the A-Frame Inspector. And when you save these changes, they are exported in HTML. And using A-Frame, you can also create augmented reality experiences. This is an example where a developer has used the camera APIs in the mobile and have combined it using the A-Frame. And this has created an augmented reality experience. You can also make such types of experiments to create games like Pokemon Go with A-Frame. How many of you have heard of Google Tilt Brush? Google Tilt Brush. Okay, so I'll tell you a bit about Google Tilt Brush. So you have an HTC Vive, and you have a room scale experience, and you have two controllers. You can use them to create 3D paintings. And this was a product that was introduced by Google for HTC Vive. And to show how A-Frame is very powerful, the MozVR team at Mozilla created a 90+ frame per second room scale tilt brush experience in just a few weeks by using A-Frame. And it's called A-Painter. In a nutshell, virtual reality is really fun, and A-Frame makes developing for web-based virtual reality also fun. The website of A-Frame is aframe.io, and it is an open source and inclusive project. Most of the work is done on GitHub. There's an active community of the WebVR members from all over the world on Slack. You can hang out there, share projects, ask for help, and people will respond to you, and it's a very active community. And there are featured projects on the awesome A-Frame repository at GitHub, and there's a blog called A Week of A-Frame blog. If you submit in pull request, you have created something really cool, they feature you on their blog. And don't forget to visit the website. So I conclude my session. Any questions? I haven't used Blender or Maya, but if they can be exported in .dae, .obj, or .met files, they can be. Yep, they can be included. Yeah. Yeah. Uh, Hardware requirements. Okay, so if you do you remember the scene that was shown in the slide where I demonstrated the A-frame inspector, anime UI? So that worked in my iPhone 4S. So yeah, that's like it's just WebGL and no special hardware requirements are required. You need a gyroscope, but that's it. Yeah, it's like entity component system, and you can add, make and like define new components, and there are components about that for in the A-frame registry for physics and like game development is possible, like just like Unity because they have these dynamics in them as well. Yeah.
Do you have an idea when A-frame and similar will get compatibility with major browsers, not just Nightly, Chromium, etc.?
So probably it would take a while for WebVR to mature more so as to be used in production scale, but like most of the browsers have already started implementing it. I mean, if you work on like Google Chrome on your mobile, you'll be able to handle the same experiences. Yeah. Yeah.
Is there any way to create an interaction between the A-frame and the HTML page?
So,
Like
I
embed?
yeah, you can. You have the HTML page. A-frame is HTML, and you can put in anything. You'd put in a regular website. You can put it JavaScript code in it. Yeah, it's like. Did that answer your question? Yeah.
What about loading issues? The models could be huge and take a while to download the things. Is there any way to
Uh,
lazy load the
which
models?
issues? I didn't get you.
Sorry, about the loading of the models on the client side.
Loading
It
of
could
the
be huge.
models. It depends upon how heavy the models are. Uh,
Is there any way to lazy load the things or something like that?
Not that I can think of currently, but I mean, it's probably depends on how heavy they are. But perhaps I can like research and I can get back to you on this. Yeah. Yeah.
These technologies are great for gaming and stuff like that. But what do you think about the evolution of virtual reality also in enterprise business? For example, do you think that will be adopted in some way? Do you see any other kind of evolution of these technologies?
So, like I mentioned in the beginning, that there are okay. Let's move aside gaming. Then there are different use cases. Like you can use it to visualize your drawings if you're an artist, or say you are developing some 3D simulation of a car. You can. It's easier to visualize in that way. And like Samsung is working on therapeutic causes to help people get rid of their phobias, like acrophobia, fear of heights, in a safe and controlled environment. So these are some of the applications, but from what I've heard, as for application in industry, I think like there are a lot of hackathons being held these days. For instance, there was a recent one at Russia. So like these are startup hackathons for people who are interested in visualizing stuff. Like you have IKEA, and you can visit their website, and you can put in some dimensions, and they'll give you a rendering of how the new sofa would look like in your apartment. Would it take too much space? Wouldn't it? And how, would it look good in the same settings? Yeah, these are some of the implications. Yeah.